Gammon, the trusted name in the field of civil engineering constructions. Its successful track record of several decades, creating imprints across all sectors of civil engineering, is the living testimony of its commitment to the time and quality. Some of the landmark projects, right from the historic Gateway of India to recently inaugurated Signature Bridge of Delhi, entails the contribution of Gammon to the growth story of infrastructure in India. Vyasi Hydroelectric Project is a run-of-the-river scheme on River Yamuna in Uttarakhand. The project consists of a concrete gravity dam, head race tunnel and powerhouse of 120 megawatt capacity. Gammon is awarded with construction of dam and part of head race tunnel. 207-meter long dam with 93-meter height is to be built in 13 blocks. There are 5 overflow blocks at the center and 4 non-overflow blocks on either side. Total concrete quantity of dam is approximately 4 lakh cubic meters, which is placed layer by layer to create the dam wall. Lift height for first few layers will be 1 meter and subsequently it will be 1.5 meters. To avoid the thermal cracking in the dam, the temperature of concrete at the time of placement is kept at 12 degrees Celsius. To meet the construction schedule, the peak requirement of concrete is 125 cubic meters per hour. Considering ambient temperature of 37 degrees Celsius and heat losses during transport and placement, the temperature of concrete at the batching plant is maintained around 10 degrees Celsius. The aggregate for dam concrete is produced at a 3-stage crushing plant set up to crush quarry-run materials. A separate screening plant with sand-making machine is installed for screening of riverbed materials. The complete concrete production unit on the downstream of dam is planned at micro level to meet the peak requirement of concrete at desired temperature. Concrete production unit consists of aggregate storage bins, reclamation tunnel, belt conveyors, inundation bins, dewatering screen, reversible belt conveyors, ice plant, ice handling system, chilling plant and batching plant with cement storage silos. The plant layout is planned to facilitate ease of operation and maintenance. Aggregate from crushing plant is transported to storage bins by means of dump trucks. Aggregate from storage bins is extracted by using vibro feeder installed in reclamation tunnel. This aggregate is fed into inundation bin through belt conveyor BC1 and BC2. Inclined belt conveyor BC3, which is having tripper arrangement with flap gate, ensures that aggregates are fed into respective inundation bins. 1/3 capacity of inundation bin is filled with chilled water at 3 to 6 degrees Celsius. Then the aggregate is added and more chilled water is filled up till the overflow level. Continuous recirculation of chilled water for about 20 minutes brings down the aggregate temperature to around 13 degrees Celsius. Then the water is drained through the discharge pipe. A total of 6 inundation bins of 100 cubic meters capacity each are used alternatively to maintain uninterrupted supply of aggregate. The watertight gates at the bottom of the bins are opened to discharge the aggregate on conveyor belt, which carries it to vibratory dewatering screens. At dewatering screens, all the leftover small particles and water in the aggregate are screened out. There are 3 dewatering screens in the complete circuit. After dewatering screen, the inclined and reversible belt conveyors carry chilled aggregate to batching plant hoppers. 4 IBT-type chilling plants, each with a capacity of 125 TR, supply chilled water to inundation bins. Insulated water tank of capacity of 3.25 lakh litre is set up for storage of chilled water. Network of water pipelines from chilled water storage tank to inundation bin and further to sedimentation tank is meticulously designed to meet the water requirements and sequence of operations. Rotex make pneumatic valves and control system is used for reliable operations. Sedimentation tank of 3 lakh litre capacity is used to collect drained water to recycle water for inundation bins. In addition to pooling of aggregates, ice flakes are also added to batching plant to maintain the concrete temperature at desired level. For this purpose, 7 ice flake plants of 25 TPD capacity each, an ice handling system with day tank and metering device is used. Elevation of ice maker and ice storage room is maintained in such a way that angle of ice screw conveyor is not exceeding its permissible limits. Ice maker is installed at a height of 17 meters above ground level. Right below, there is ice storage room of 150 ton capacity. This tower type installation of ice maker helps to achieve smooth handling of ice flakes. Complete concrete production unit is fully automatic with data logging system, which is controlled through PLC. The automated process sequence follows a well-designed path. Conveyor operations are interlocked with each other. Zero speed switch, belt sway switch, pull cord switch, emergency push buttons. All these systems ensure our highest commitment to safe operation of the plant. Controlled temperature concrete is placed in the respective block by using tele-belt, truck-mounted placer boom, concrete pump and tower crane with concrete bucket. Tower cranes are also used for handling shuttering and reinforcement steel. It is for the first time a complete system of aggregate cooling that consists of inundation bins with watertight gates is designed, developed, fabricated and commissioned in-house by Gammon. This well-designed, fully indigenous plant is a testimony of Gammon's commitment to delivering the highest quality of work in its pursuit of excellence as builders to the nation.